Hey everyone, my name is Kenny Coleman. I am an open source technical product manager here at VMware, and today we're going to be looking more like a Kubernetes 101 session. And we're really going to be looking at what is Kubernetes for the virtual infrastructure admin, or what does it really mean to people that are dealing with vSphere on a day-to-day basis. And the way that I typically learn, I learn through spoon feeding and making sure that everything is about as easy as it can possibly be. And I do that a lot with creating analogies. And so today we're going to be looking at actually mapping some of the virtual infrastructure components to the Kubernetes components. And when you do that, you're going to have a better understanding of not only just the architecture, but how some of the Kubernetes components, how they start interacting and they start segmenting into the realms of networking as well as storage. And then you can also get an understanding of how do we operate this at the same level as well. So as a quick overview, we need to understand how containers are disrupting the status quo. Virtual machines simplified operating systems by providing this common virtual hardware that was abstracted, and really it made the underlying infrastructure not as complex. And you can think of containers as abstracting the operating system from the application, meaning that now I can package up not only the application, but all the dependencies for that application, regardless of the operating system running on it. And if you go out there, there's plenty of websites that are going to show the trajectory of container adoption over time and how it's compared to virtual machine adoption. So it's coming at a very rapid pace. And the driving force behind any shift, and we can look at this through the out of history, it always looks at the root cause is going back to applications, an application development, application, really the journey of it. And the container movement is happening because of just new application architectures. We're hearing stories of companies who are deconstructing their monolith, and they're starting to create smaller services that can be maintained and upgraded independently. And this in turn is now allowing a person or a team to own a particular service and be responsible for how it communicates and how it hooks into the rest of the application. But at the same time, it also allows experimentals like product sets or features to be implemented without affecting the core components. And containers are really exposing their service, and that becomes the core construct of how this is really looking and how this is continually mapping as well. So as I mentioned, I learn by using analogies. I take something that I'm already familiar with and mapping it to sort of like a new idea. So if we take this into just a practical comparison of really what is a container versus a virtual machine, virtual machine was able to take the constraints of physical hardware and make them ubiquitous. And this allowed the operating system to have virtualized hardware. And this in turn allows the operating system to own the dependencies of the application as well. And these dependencies can be tied to certain versions of, say, Ruby or Node.js or Golang, and the operating system needs to have these installed. Of course, this actually can limit maybe multiple applications that are running on a single virtual machine because of this dependency or even a language dependency. So once the dependency is in place, the application can be deployed in a multitude of ways. Now with containers, the abstraction layer is starting to move up the operating system moving to the operating system. And the container host is now becoming your operating system, and the only dependency it requires is to actually have the container runtime installed. From there, your application and its dependencies are wrapped inside the container. And the container itself is sharing the kernel and its properties from the container engine. So we can have multiple containers, each having its own application with different dependencies, such as if I have one application that's utilizing Golang 4 in one container, and another application that's using Golang 1.12 in another, I can do that because the host is now sharing, or there's now sharing the same kernel underneath of it, or underneath the covers. And at this point, the compute network and storage, this all becomes yet another layer of abstraction that happens from the physical infrastructure. So if we look at what a container ultimately is, it's just a runtime file. It's pretty easy, as you can see. So from here, we're starting with a base image. In this example, it's Ubuntu 14.04. We're saying I want to go and install the Redis application. I'm going to expose a particular port, which is 6379, and I'm going to use this command to actually spin up the Redis application, get going. And before, when I needed to do this with a virtual machine, it required me to have a base operating system. I had to have some sort of configuration management technique to configure the operating system, as well as to install any sort of dependencies. And then I had to lean on other configuration management tooling to actually install and run that application. But now we can take something as simple as a Docker file. We build our application through it using these series of commands. We can push it to a container registry such as Docker Hub, or if you're running locally inside your own data center, you can use something, we have an open source project called Harbor. And from there, the container host will now issue a Docker run command that will then pull from a registry, and that runs the application with all the dependencies it needs. And this makes any application running in containers super portable in a way that really virtual machines just couldn't do. Because you could make this same exact application running in your own data center or running in any sort of cloud, and it builds and it pushes and it runs the same exact way no matter where it goes. And if you're looking at actually figuring out how do we start migrating some of these applications, what are the types of applications that we can containerize? Well, this chart is going to be helpful in knowing what sort of level of complexity we can actually accomplish. So going from left to right, we can see the progression. So in bucket 1, we have our independent software vendors, or we have off-the-shelf software, and this is coming in some form of binaries. You have no access to the source code, you have to build it based on a series of trial error, and you might not end up actually getting there. In bucket 2, you are kind of in the same situation, except you're looking at a vendor to provide you with the best possible way of running it inside of a container and giving you the images to actually make that happen. Bucket 3 is software that for many enterprises, they struggle with containing because it's using .NET. Now, this is getting a lot better because as time progresses, Windows support is getting better. However, it's still tricky today, and even the next version of Kubernetes, we're going to see Windows as a GA feature, and so you're going to see Windows become a lot more prolific. However, it's still going to take time for the rest of the industry to sort of catch on, and a lot of developers catch on there as well. So if we keep on moving further to the right, we look over at bucket 5. And this is where we have more modern types of applications. Now, this was using Java or Spring, but there's all kinds of things that you can do with Node and Golang to actually start breaking out a lot of these applications, start running in their own services. And these are types of applications that were purposely built that have containers in mind. Now, we've talked a lot about how Docker is making this all possible, but Docker alone gives us only part of the functionality we need to successfully run at scale. So if we were to run and take a single application that has multiple container components, as you can see, we've got 2 web servers, a load balancer, and the application backend. It can be ran, but we miss out on some of those higher level pieces. We don't have any availability. We don't have the ability to scale when we need it. And this is why we look at using a container orchestrator. Now, we could give a history of really where this has been since 2013, 2014. However, it's easy to say that at this point, Google has won the battle. And that's why we're here talking about Kubernetes. Kubernetes has really emerged as the de facto standard and the container orchestrator that every container technology company is building and supporting around it. So Kubernetes provides the ability to use a Docker container, but add higher level value, such as scheduling, service discovery, resource management, and much more. And you can build these all into sort of these runtime applications that are all built in YAML files. And these are all done through pods and deployments and replica sets, which we'll talk about a little bit later on. Now that we have an idea of why we need Kubernetes, let's look at the architectural components and how that starts translating into the vSphere environment that we all know and love. So Kubernetes has 2 main pieces. You have the control plane, which is our master nodes, and then you've got sort of this data plane, which is our worker nodes. And we're going to take look at each of these at kind of a fairly high level. We're not get too deep in the weeds, but just enough that you can come away with understanding what this architecture looks like. So the Kubernetes scheduler is policy rich. It's also topology aware. It makes snap decisions that affect availability, performance, and as well as capacity of the cluster. It takes into account resource requirements, quality of service requirements, hardware, software, policy constraints, affinity, anti-affinity, data locality, workload interference, deadlines, and much more. So as I'd mentioned, it's super, super intense and rich of really what it does and what it can offer. And the API server is really this central communication hub. It provides REST-based services for these components to all talk to one another, as well as where, as an admin or as a developer, this is where you're going to be interacting with it when deploying your applications. The Kubernetes Controller Manager is a service that watches the shared state of the cluster. And it's doing this through the API server, and it makes changes attempting to move the current state towards a desired state. Now, there's also packaged in what's called the Cloud Controller Manager. And this is a daemon that embeds cloud-specific components that are shipped with Kubernetes at this time. And this could be pieces that are relating, how do I run Kubernetes on top of AWS? Or in our case, how do we run Kubernetes on top of vSphere? So there's the vSphere Cloud Controller that is shipped with it. And these two make up everything needed for managing the running state. And then we have the scheduler. This should be pretty simple to understand and recognize that this is going to be watching for new pods as they are requested or as they are created. And then we have etcd. Etcd is like our database here. It saves the current state of the cluster and is really what's needed to be in a healthy state to make sure that we have our control plane always up and running. This is also, as you're going to see, more product sets that are becoming online, other open source projects that are looking at how do we back up the state of Kubernetes, and it's going to be looking at etcd and taking a lot of the stuff that's been ingested into it and actually saving that off and being able to restore it from there as well. Now, this is pretty similar to what happens in vCenter. Instead of etcd, we have our database, which if you're using the appliance or if you're using any other sort of server version, it's using some flavor of SQL to make that happen. And as usual, there's a scheduler that places VMs on certain hosts and workloads within inside of your cluster. There's also going to be all kinds of services that are built into vCenter. Now, these services are a little bit different because you have things such as the web client, inventory, licensing, and much more, but not everything is communicating over a singular API construct. However, there is an API service that's available, but not all of these are talking through API services. But as you can imagine, a Kubernetes master is analogous to what you would understand as your vCenter, really what's controlling your cluster at this point. Now, the control plane of Kubernetes can scale as well. There's a lot more complex configuration that needs to take place that we're not going to be going into, and it's not mentioned in this diagram, such as front-ending all of these with additional load balancers, as well as making sure that etcd can now replicate changes across the cluster. But that's what has to happen, is all these nodes are now talking to each other, and it's providing a highly available solution for your master components at this point. And the data plane, of course, is where our workloads are running. We start off with a base operating system. It has the container runtime installed, as well as our two Kubernetes components. Now, we'll talk about the kubelet first. And this is sort of like a Kubernetes agent. It's responsible for issuing commands on the local node when it spins up pods. If you're not familiar, each pod can contain one or more containers, and that's how applications are now packaged and deployed and ran. The kube proxy, on the other hand, is exactly that. It's a network proxy. It can do simple or round robin TCP, UDP, or SCTP string forwarding across your choice of any type of overlay network that you can choose. And overlay networks is a requirement of running Kubernetes, and we'll examine that a little bit later. The kubelet is in constant communication with the API server for resource monitoring, heart beating, all those types of things. And of course, this is pretty analogous to what we see in our vSphere model. The ESXi worker is not something we typically interact with. However, it runs our virtual machines, it runs our workloads, and it continually talks to vCenter as its main source of communication as well as orchestration. And now we have to figure out, how do we access our Kubernetes, or how do we interact with it? And it's a bit different from vSphere. Most of us are ingrained with the instinct that we use the vSphere web client to perform everything we need. Then we learn how to use other types of tooling. There's things like Power CLI that we can use to automate some things, or we use some type of CLI-based control mechanism. Of course, we use vCenter as the main touch point here to actually interact with all of our workloads or to deploy applications or anything like that. In Kubernetes, it's kind of the opposite. You use kubectl or kubectl, which is a binary that is used on any computer to access the Kubernetes API server. So from my local machine, I can have the kubectl binary, and I can have my RBAC, whatever types of access to actually talk to my API server, and I can now communicate with Kubernetes. And this CLI, or this binary, today it's what's used to issue commands, and it kicks off any application deployment. And around 99% of the work that you're going to do today is all done through this command line tool. And Kubernetes does come with a GUI, but it's read-only, and for the most part, it's only used for resource-based consumption statistics. It's also kind of a security risk to actually have it running inside of your Kubernetes cluster. So by default, it's usually turned off or it's not deployed. Now, there are other GUIs that are being developed, like Scope from Weaveworks, but you have to really become comfortable with the CLI for a while to understand how to interact with Kubernetes, really from any application or even from an administrative standpoint. Now, if you're interested just to see what the CLI can do, I've highlighted some of the most common commands that you're probably going to issue. So apply and create are very similar. With these, you're going to be using them to actually apply a policy or create a deployment from the API server. The only difference is that creating is an initial creation. Apply is now applying and creating both at once. Now, when you need to look at running more instances of an application, you can probably guess that we're going to use the scale command, and that's when that's going to come into play. When you're looking to update, you can now use rolling updates to update the pods in a fashion where there's not going to be any hiccups in the application. And lastly, if you need to get into the container for any reason at all, usually it's kind of like a bad practice, but if you need to get into the container to see what's going on, there is the exec command, and that's sort of similar to the Docker exec command if you had used that in the past. So it kind of just pushes you in there inside of a bash terminal. So on a final note about the architecture, the container is just wrapping your application. The pod runs multiple containers for your application. The worker node runs the container runtime, as well as the Kubernetes agents. And the control plane is where your management components and all this run on top of vSphere as well. Now, going down a little bit deeper, this is when we start look at mapping more components from Kubernetes to our infrastructure. And if I'm going to say anything, this is probably the one slide you should pay attention to, because if I'm an application developer and I want to provision a deployment, I'm going to issue the commands, and that apply command is going to go to the Kubernetes API service. So in this instance, I'm trying to provision some sort of ELK-based application. The application has anything that's built into it for my deployment. It can have specific requirements for resources or affinity policies, security policies, and how it's going to be accessed from the outside world, maybe using a load balancer. It's also going to have things of how is my application storage going to be managed? Is it going to be done through persistent volumes or something else within inside of here? As well as how are my application metrics, how are these going to be pushed out for continual monitoring? Now, as a vSphere admin, these can all be tied back to components that exist today. You've got your compute, security, network storage, monitoring, all these different kinds of applications. And as a vSphere cloud provider inside of Kubernetes, we have to figure out how this is really going to start mapping and where the workload direction is really going to happen. So NSXT can take care of network security profiles, as well as being one of the only on-premise solutions that provide a load balancer primitive from Kubernetes. If you go and start doing some research, you're going to find out that NSXT is really one of the only ones out there that can do that. The vSphere cloud provider, as I had mentioned earlier, is how we manage our compute and resource availability where things are being placed, but as well, this is also what manages our persistent volumes and how these are orchestrated. And at the same time, it orchestrates all the necessary steps that are needed to create, attach, and mount a VMDK from a worker node, a VMDK to a worker node, so data can then be preserved after that life cycle of the container or after that application has ended. Lastly, integrations with Wavefront and vRealize operations can continually monitor that application in the infrastructure. And from here, we can kind of see how this mapping happens and how we can continually keep deploying any type of application and really where that mapping is happening from the Kubernetes infrastructure to your vSphere infrastructure. Now I'm going to really look at what's the difficulty of doing this. We understand some of the concepts of architecture. Next is we need to look at what does it take to actually spin up our Kubernetes cluster? What's it take to actually get off and running? And one of the things that we start looking at, if you start looking at how do we, or just Google it. I can say just Google it and look at how to install or how to run Kubernetes. You're going to come across the Kubernetes documentation, and there are choices upon choices upon choices of different types of ways to get up and running. And this could be a turnkey cloud solution, whether it's running any type of cloud. It could be an on-premise turnkey cloud solution, or it could be as much as completely custom and you want to do it yourself. Because you don't want to say you don't want to try to pay for a service. This is all open source software, so you want to try to do it yourself and kind of get used to it. So let's look at the open source way and really what it takes to get this up and running inside of a vSphere sort of environment. So the first thing that we need to do is we have to choose a distro. Now you might think that, okay, well, I've already got my vSphere golden image, I got that templated ready to go. But do you have everything that's set up that's needed to actually be ready to install or be able to use Kubernetes, whether it's the components, whether you have the Docker runtime installed or anything like that? So you've got to figure out which distro. It's the simplest way as we get back down to zero. Now you can choose regular standard distros like Ubuntu or CentOS, but then you have some that are more container centric, such as CoreOS or Rancher OS. And then there's even one that was recently announced, which is Talos, which is another open source that's more along the lines list of focused on being Kubernetes only. And now we need to make our distro configurable. So I need to use a template or an AMI. I got to configure this golden image. And if you look, just Google out there, if you haven't done it in a while, say, how do I make a golden image with vSphere and CentOS? And you're going to get hundreds of thousands of Google results. And most likely, these are going to be out of date. And so you've got to figure out exactly how do I maintain and how do I keep up with this? And how is the template going to work in my environment? Just for instance, if you're using something like the Ubuntu cloud image, that's not going to work if you have an environment that's reliant upon static IPs, because it's reliant upon, or should I say that particular image uses only DHCP. So you've got to figure out exactly, is the template process or is this blog or whatever you're looking at going to work for you? In addition, how far do I go with this? Do I install the Docker Kubernetes components? Do I automate that with some sort of bash scripting or configuration management after the fact? And lastly, one thing that's really, really hard to do is sizing. Do I do 2 vCPUs and 4 gigs of RAM? Do I double that? Do I triple that? I don't really know. I don't know your applications, and odds are you might not know those either. So figuring out exactly what size of these workers that you need to spin up is another difficult task just to assume and do on your own. Then you start looking at, okay, customization of the Kubernetes components themselves. We all use and know Docker very familiar because it's been around for a long time. However, Kubernetes is built with abstraction in mind. So if you don't want to use Docker, you can use something like Rocket or some other type of container runtime interface compatible offering. And if you're going to use Docker, have you done Docker in production before? Do you know what it takes to actually do log rotation? Do you know how to do anything with choosing your correct storage driver, whether you're just going to choose overlay FS or something else? These are all things that you have to think about before you are beginning even going down this path. At the same exact time, Kubernetes and Docker, they sort of have this matrix of compatibility. So even though you want to use the latest version of Kubernetes, that doesn't mean the latest version of Docker is going to work with it. And if you're building your environments based off yum install docker CE, and you are trying to be a good admin and update it and make sure you have the latest security features or patches, and you do a yum update, what's going to happen? Well, it's going to go ahead and it's going to overwrite that next version of Docker. So these are things that you think about just when you're building, just installing the software itself. And lastly, if you're looking at just architecturally, do you want to go single or multi-master? And at first, I know you think, okay, we always want to go multi-master. We want the highest availability. You just showed me the architecture document. Yeah, there's a lot of work that goes into actually getting a multi-master environment up and running with certificate sharing, load balancer, DNS, everything that has to be done to build that. And lastly, etcd is a big part of this. You don't have to have etcd live on the master node. You can actually have your own etcd cluster outside of it. So you can figure out, how do I manage this? Again, more choices on figuring out what's the best way and what's the best path forward. Next, you have to figure out networking, because as I mentioned earlier, you have to have some sort of overlay networking construct within inside of Kubernetes. And if you go through the documentation, you're going to see this familiar image. And this image is showing you exactly how to install these different types of overlay networks to your open source Kubernetes cluster. And from there, you have to figure out, well, what's better? Do I use Flannel? Do I use Calico? Do I combine them both and use Canal? Is there more of a benefit to using something like Weave? There's a lot of blogs out there. You've got to try to read and figure out which one is going to have the types of feature sets that you need, as well as having the performance characteristics you need as well. And each one of these requires some special set of instructions during installation using kubeadm, which we'll look at here in a minute. In addition, how do you troubleshoot this? If you're an enterprise and you want to understand exactly what's happening inside your cluster, there's not a whole lot of tools that exist of how to troubleshoot when one container isn't necessarily talking to another container. And how do you manage this at scale as well? And for the most part, there's not a lot of companies out there that have figured out what the scaling point is, whether it's 10,000 containers, 20,000 containers, 1,000 containers, who knows? This is kind of a, your mileage may vary some sort of scenario based upon how comfortable you are actually deploying this and running this on yourself. Now, we're still not ready to install yet if you're going to do this, because persistent storage is a important factor when we're doing this, because the one reason why Kubernetes became so ubiquitous and became so popular over things, something like platform as a service, is platform as a service was really geared towards doing applications that didn't have, web servers or application servers. They didn't really necessarily rely on a database or anything like that. Now we can actually run databases. We can run Redis. We can run MariaDB and SQL and all these different things inside of containers. So we need some sort of backing that when we know that the container lifecycle is ended because it's an ephemeral type of technology, that data is still going to be there and it can be revived and retrieved at a later process. Now, with inside of Kubernetes, there's a continually evolving process. Today, we have the in-tree cloud provider. And this is really, there's only about 12 of them that exist. And vSphere is one of them. Everything's moving towards CSI, or the container storage interface. Again, this is Kubernetes being a little bit more playful with inside of the ecosystem to now allow more vendors to do this. And it also allows vendors not to have to be in-tree in part of the core Kubernetes code. So now we have plugins that are now being created, and you're going to see those become a little bit more prolific over the next year or two as more people are starting to move that way. And in addition, there's not a whole lot of examples out there that show you how to actually build and utilize a particular type of cloud provider when you're actually building your Kubernetes cluster. And we're guilty of this too. VMware has some pretty bad documentation on how to use the vSphere cloud provider. However, it's getting better, and I'll show you some examples on a blog here in a minute. But even if you're trying to do this with kubeadm, even fewer cloud examples are there. Even for major cloud providers, AWS doesn't even have one available. You actually have to go to Scott Lowe's blog to figure out how do you install kubeadm with the AWS cloud provider. So there's a lot of work here that needs to be done. And so as you can imagine, this is still ripe for a lot of improvement out there. Now, I talked about kubeadm a lot. So what is kubeadm? So from the Kubernetes documentation, it's as simple as saying that it is a quick way to build a minimum viable cluster. And it really is. It's a simple one-liner that you can use to then build your Kubernetes cluster and have it up and running. However, it's a binary. It's a tool. It's not meant to be an all-encompassing solution. So it's expecting more higher level tooling to be built on top of it to do, say, management of clusters or performance monitoring, anything like that. This is just for building clusters and building conformant clusters out of the box. But really what this means is that Kubernetes is hard. It's a tool that builds clusters well, but it doesn't go beyond anything that is some of like the generic installation pieces. So really, it's going to be dependent upon the maturity of your organization to figure out how you can adopt this. And just to give you an idea of what it takes to actually build this, this is sort of all of the components that you have to do. And I had built a bash script that does all these. So I created master VM, and these are all the bash scripts that are all the commands that were written into a bash script that shows exactly what it takes to actually stand up and get your first master VM up and running. So I disable the swap, I implement IP table rules or disable the firewall because I'm a bad admin and I don't want to deal with firewalls at this point. I have to install Docker. I have to make sure that Kubernetes repo is ready to go. I configure SC Linux. I enable my kubelet, evaluate which CNI I want to use, and then I use KubeADM finally to build and initialize the master. And from there, I have to create a custom vSphere configuration file that has some of my passwords or some of my secrets and how I'm actually configuring this so it's actually talking to my vSphere environment as well. Lastly, I restart all the services and apply a default storage class to use persistent storage. After I've got my first master made, I now can create my workers. I follow some of the same exact setup, and it automatically joins to my worker VM. Now, it's a lot easier when you look at this, but in reality, this takes about a 20-minute process if you haven't already built, and that's just building a bash script. If you wanted to just build this and do this on your own, and you go through the experimentation and figuring this out, you're going to be spending a few days trying to figure out exactly what it is and how you build this all on your own. But now we built it, it's easy that we can build it, but what about day two? That's one part where people typically forget because it's more than just the installation of our infrastructure. We've got to worry about how do we operationalize it. So you've got everything from logging and monitoring, dependency management. How do we deal with upgrades? And one of the big things here is automated repeatability. I say this because through our research, we found out that unlike vSphere clusters where people are making 25, 50 node clusters and it has a lot of workloads in there, instead of having large Kubernetes clusters, there's more smaller Kubernetes clusters that are being deployed. And you do this because it can be based on the types of applications. It could be the BU, it could be a DMZ, it could be any sort of reasoning behind it, but you can have your applications be separated by these types of control planes. In addition, you've got regression testing, and lastly, your line of support. So you've got to figure out what is my organization's level of maturity and the willingness that I'm actually able to spend on figuring out the rest of these on my own. So now you're asking, okay, great. Well, this is what you do on your own. Start queuing it up. What does VMware have to offer? And that's really what we're going to talk about, because one thing that you have to understand is that Kubernetes release cycles are every 3 months. There's a new one that's coming out. And so you've got to make sure that all your components are working. It's integrating with your storage and your networking, as well as your security policies. At the same exact time, it's working with all of your applications. And you have to test this through every cloud provider that you're wanting to support. And so this is why VMware Kubernetes has a large portfolio where we can look at how do we get a quicker ROI or return on investment of our solutions. We can look at updates and the maintenance that's now verified by the assembler. You get deterministic capabilities and feature sets. Support becomes common instead of custom. When you build it your own, you have this sort of one-off. When you take a off-the-shelf product, it becomes a little bit more easy to support it at a larger scale. And common components really create tighter integrations, and that develop enhanced capabilities of what you can do. And this is really just going to create a better all user experience. And so when we look at these different product sets, we start from the left to the right. And when we look at the Essentials PKS offering, we're looking at a more modular approach. What's it look like to build it with you? Say you want to choose your own networking construct. I want to manage my clusters utilizing Kube8EM. And that's fine, you can do that. It's a little bit more hands-on approach. However, it's more custom and you can build it the way that you want. In the middle, you have the Enterprise PKS offering, and this is more of a turnkey solution. Now we can utilize a singular command to automatically deploy, configure, and make available Kubernetes clusters. And when I say make available, not just a Kubernetes cluster with a single master, but I can do multi-master creation inside of Enterprise PKS. So this allows me to have a lot more control in regards of how do I manage multiple Kubernetes clusters. And I can do it all from a singular command line set. So it's more along the lines of those people that want something that's ready and easy and nice to use out of the box. And then moving to the cloud PKS side, this is where you're not owning any infrastructure at all. Now, if we compare, and this is a lot happening here in this slide, but if we compare some of the Kubernetes components and focus areas to what it looks like with a DIY approach versus using one of the PKS offerings, you can see that you're really in another area where you're spending a lot of time actually figuring out how do we build this, spending a lot of time figuring out what are the choices that I have to which container registry do I want to use, which network overlay do I want to use, do I have any logging mechanisms built in, versus when we look at sort of the enterprise and the essential side, we can see that the enterprise side has a lot of stuff that's built in. There's a lot of things that are now being automated for us. We have one-click provisioning. We have native integration into monitoring and logging software. We have tight integration into our NSXT platforms to be able to make sure that we can create port groups and we can create load balancers, and we do all these different things with inside of here, as well as have also more security features such as micro-segmentation and firewalling. It also comes with a container registry, so we can have Harbor and we have CVE scanning that is built into it as well. And when we go down the essential side, it's along the same lines, but now we provide guidance. We provide valid reference architectures on how this is all built, and you have more control over what your Kubernetes cluster looks like. So each one fits into wherever you fit as well. So now that we understand the architecture and how it maps to vSphere, in addition to the difficulty when it comes to building a Kubernetes cluster on your own, and now we have some more of the commercial solutions that we can look at as well to make it a lot easier, let's examine some of the higher level constructs of deploying your first applications. So labels in themselves are really what help us tie Kubernetes components together. We can label particular volumes, so only certain containers can access them. In addition, we can map it to our higher levels, such as saying that we want a load balancer needs to tie itself to a particular service. And we can call that front end service for multiple types of applications. And in this case, we have one application called Hello. Now in the vSphere world, we use labels as well. Probably the most notable is using storage policies. We create a new virtual machine, we attach a storage policy, and it allows one or more data stores to be utilized that match that particular policy. In addition, there are also tags and custom attributes that can be used by a multitude of other applications that are out there. Now, a replica set is one of the core pieces of how applications are running inside of Kubernetes. And what this does is that it makes sure that multiple copies of an application are running. It's fairly simple to see how this is functioning, but to be honest, you're never going to be running or deploying a replica set or even a pod on its own. In fact, that's why we look at a higher level construct that's called a deployment. And a deployment is going to take all these lower level constructs, such as the replica set and a pod, and it's going to orchestrate all these and roll them out based on our own needs. So whether it's how many replicas, and it's also going to be looking at, in the replica set as well, is going to be making sure that we have that in state, and that controller service is going to be looking at that in state as well. And then we need to finally access an application. And I know I'm running through these pretty fast, but this is really step 3. It's funny because when we start looking at how people start learning Kubernetes, they start learning this way first instead of learning exactly how you build it. Instead, they dive in first of actually how you deploy applications. But there's a lot of things that are new that you have to learn on actually how to understand and utilize applications that are built inside of Kubernetes. And the service is one that we use to actually access the application. We create services, and then we can now expose pods based on labels that we had created previously. And these all end up tying back to each other in sort of meaningful ways. And we've only scratched the surface here. There's tons of items that we haven't had to cover, and a lot more concepts such as namespaces. Namespaces are really isolated places where workloads and can actually run, and you sort of have this separation, this delineation for users and projects. You also have ingress. This is a new way, a form of actually taking layer 7 load balancing. It still interacts and has a lot of connections to NSXT, but from here, you can actually have a single IP and have a slash where the application is then being pointed to and how you can actually access that application. You have jobs, there's auto scaling. You also have daemon sets. Daemon sets is a pretty interesting one where instead of having a replica where a replica is going to actually, or sorry, a deployment is going to use a replica set, and that replica set is going to talk to the scheduler, and that scheduler is going to now put those workloads on different worker nodes depending upon the space or what kind of workload platform availability it has. A daemon set is something that runs on every single worker node. And this could be for types of applications that need to collect logging statistics from every single server or anything like that. So there's a lot of new and interesting ways that you can run applications with inside of Kubernetes as well. So if you're looking to get started and you just want to get your hands on with some stuff, but learn how to build your own vSphere cluster and utilize kubeadm as a part of that. kubeadm is really has a lot of people from VMware that are now working on this project, and you can stand up a kubeadm for free at playwithkubernetes.com. So go ahead, you can check that out. As I mentioned, VMware is really getting big into the space with inside of Kubernetes. There's a lot of open source contributions that are happening, and kubeadm and the cluster lifecycle SIG is one of those places. In addition, if you want to try to build your own cluster, there's a great how-to that's happened from Miles Gray's blog at blog.cloud. From here, it's a 3-step blog. So first is creating a cloud image for cloning on VMware. This is just your golden image. As I mentioned before, it uses the cloud image, so it's reliant on DHCP. So if you can use that environment, great, go on and use it. The second is actually setting up Kubernetes and the vSphere cloud provider utilizing kubeadm. So kubeadm, as I'd mentioned, you see this common theme that's happening here. And that is one of the best ways today that you can get an open source conformant cluster up and running. And so this is going to go through all the little details that just didn't make it into the docs for some reason. It's also using Flannel as the networking layer. So keep that in mind as you're going through and you're getting used to actually utilizing this particular overlay networking software. But this isn't meant to be a definitive guide, and there is not a run in production clause here, but your idea is that you can use this as a jumping off point to learn how to automate it and make it better for your environment. The third step is actually utilizing the vSphere cloud provider to create your storage classes, deploy your first applications, and getting the Kubernetes dashboard that I had talked about earlier up and running. And if you're interested on automating a lot of this, I have created a installation script that uses CentOS with kubeadm and vSphere, and you can get it here at this gist off of GitHub. And so it's going to take essentially everything that I made in that flow chart and creates it into a simple bash script that you can use to quickly stand up a cluster in just a few minutes. And if you have time, we encourage you to also check out the Handson Labs. There is a PKS Handson Lab, and what this is going to do is go through a few different things. First, you're going to learn how to deploy a cluster, which is relatively simple because it's just a single one-liner. Then you're going to go into other core Kubernetes concepts, and then you're going to look at actually deploying Kubernetes deploying applications on Kubernetes. And these are going to be using things such as persistent applications and so on and so forth. So make sure you check out the Handson Lab, because that's going to be one of your best resources for getting spun up and utilizing this and using it in a free environment as well. But with that, again, thank you for your time. My name is Kenny Coleman. You can find me on Twitter at Kendra Coleman, or you can find my GitHub at KACole2. You can also check that out if you want to find that gist to get the bash script for installing CentOS with vSphere and KubeADM as well.